G'day comrade subscribers. So let's continue. Thanks to Jason's comment last night, got me thinking properly. Yeah, so basically there is no luma information at all on the output. So I had a look in the manual and it's pretty simple. We've got this connected here, and this is an adapter box you're supposed to have. Here, a pretty cool cassette recorder, magnetophone. So this is an adapter, television, blah 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 blah. So notice the T's look like an M. So that always throws me. So this is the television adapter, which obviously it's just what it is. It's just a UHF modulator, which explains why on the TV output there is ground, the video signal plus voltage, 5 volts or 12 volts. I'm not sure. So obviously the voltage is there to run the UHF modulator. So we should get a baseband signal out. We don't need the modulator. So that is all right. So looking at how it works, so that's the schematic again. Where's my poker I like to use? I just put it away, didn't I? So this is the Intel 8275, the CRT controller here. This is the character ROM here. So you can see, I guess, the addressing is decided by the CRT controller. Then we get an output, so we get a character, character image sort of thing that goes into this K115 IR13, so which is an RG, which is a register. It's interesting how they mix Latin. So we've got the Latin D for the data, and then we mix Cyrillic as well. So anyway, interesting way of doing it. So I guess the register here is so we're latching the image of the character, but on the output we've only got a single output. So I guess what we're doing is we're shifting it one bit at a time. So it comes out from the register and it joins in here with the transistor to give us our video output. And I know the problem with some LCDs is that they don't like DC on the video signal. So like for example the ZX Spectrum, I think it's got about 2 volts. So you add in an electrolytic and it gets rid of the DC, and LCD TVs don't mind it. So, but obviously here we've already got capacitors, so this is already blocking any DC on the video signal. So to get to my point, we've got horizontal retrace, vertical retrace here. So I've checked those, they look okay, which we can have a look at that. So that's kind of like the main thing that seems to go into the video output here. But then we also have this character dot pattern that's being shifted out. So I'm thinking, what if there's an issue with this? That's why we're not getting anything. So we'll have a look at this. So this part it's a 74198 is the Western equivalent, which is an 8-bit shift register, I think it's called. 8-bit right left shift register. So what we're talking about here is, so this is the 8275, so this is the CRT controller, this is the character ROM here, and then this is the 74198, this 8-bit shift register. So these three are basically what's generating the signal. If this was faulty, great, I can replace it, but it seems to be okay. So I did have a quick look on this today and I didn't really see any activity. So maybe the issue is that we're not actually outputting any sort of, I wouldn't say graphics information, but any text or any sort of information at all, because maybe the shift register is not working. So let's have a look at that. I should have, local JCAR doesn't have replacements for this. but I'm hoping I do because I bought a whole lot of parts, whoops, for the Radio 86RK modernisation. So I'm hoping I've got some spares for this. Anyway, let's get set up and have a look. Right, so let's have another little poke around the board. Let me power it on. Okay, the board's powered on. Let me just get the light over here so I can see what I'm doing. So, okay, it's connected to ground. Board's powered on. So we can let's have a look at the CRT controller 8275. So horizontal retrace and vertical retrace. So pin 7 for horizontal. 1, 2, 3, 4, 5, 6, 7. I got it on there. 1, 2, 3, 4, 5, 6, 7. Okay. All right, so that looks pretty good. 15.48 kilohertz. Sound about right. So that's horizontal retrace, pin 7, and vertical retrace, pin 8. 48, 49 kilohertz. So it seems to be working. Seems to be, what's the word? Reasonable. Okay, so then if we go and have a look at the ROM, well, look at the register, input and output. So pin 3 is D0, 1, 2, 3. And doesn't really, just seems to be high the whole time. Not really, yeah, it doesn't seem like it's really doing anything, does it? So that's the output from the ROM. Maybe it's the ROM. Maybe it's the ROM that's the problem. What's the 2716 pin out? So D0, I can't really read it. 15, 14, 13, 11, 10, 9. So D0 is pin 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe it's the ROM that's the problem. Are we getting addressing into it? Pin 8. 1, 2, 3, 4, 5, 6, 7, 8. Alright, so that's A0. That's A0. That's A1. Alright, so it's being addressed. A2 is pin 6. So we should be getting data out, but we're not getting data out by the looks of it. What was it? Pin 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's a 24 pin 12. Alright, so on the other side here is 13. So 13 is D3. Well, you reckon the ROM? Maybe it's the ROM. Not giving us any data out. 11 to 13. Was it? So was it? That was 12, which is probably ground. That's 11. That's D2. I reckon maybe it's the ROM. So having another look, and this is why I haven't finished the Radio 86, because they're both 2716s, 2K ROMs, and I'm not sure if I can actually burn them. I might have to have a try today. So, yeah, CRT generator, 8-bit shift register, character ROM. We're seeing addressing going in, but there doesn't seem to be any data coming out. So maybe that's the issue. Maybe it's the ROM. So the first thing I need to do is desolder it. What I could do is, I'm just trying to think of anything. It's just anything, because any 2716 with data on it, it may be even a blank one, as long as it's outputting something on the data lines, perhaps. Even if it's a blank one and it's outputting just FFF or zeros or something, at least that's something. All right. Try and desolder that. Now, I know you're about to write a comment, so yes, let's just double check what's happening with the chip select on the ROM. So I think there might be an error on the schematic, because the schematic has got, okay, pin 18, which is program / output enable on a 2716. And pin 20 is chip select or chip enable. No, output enable. Okay. So pin 20 is output enable on 2716. I know this isn't strictly a 2716. Let's assume it is. And then pin 18 is chip enable / program. So they're both active low. And they've got chip select, pin 20, from what I can see. Pin 20, output enable, connected to VSP, which is pin 35 on the 8275, and then 18, I guess, to ground, so it's always active. So 18 is chip enable. But if we actually have a look, so VSP on the 8275 is the video suppression. Output signal used to blank the video signal to the CRT. It's active when horizontal, blah, blah, blah. Okay, anyway. So they're using VSP output from pin 35 to pin 20, apparently. But pin 20, so this is maybe, I don't know, maybe I need to double check the data sheet for for a K573, what is it, RF2. Because when I check on here with continuity, so is it 24 pins? So that's 12, 13, 14, 15. Let's bring the light over here. 13, 14, 15, 16, 17, 18. So 18, you can actually see there's a physical track to, I think, pin 35 there. So 40, 39, 38, 37, 36, 35. So yeah, so that's that track there. So pin 35 is actually connected through to pin 18. So pin 35 is connected to 18, not to 20. Unless, I don't know, this is their strange way of writing it. And pin 20, so that's 18, 19, 20, I think is actually tied to ground. What's ground? What's the ground pin? 19 is got to ground. Let's just check what 19 is. There. So pin 20 is tied to ground. So on a 2760, output enable active low, so that's tied to ground. So output's always enabled. Okay, that makes sense. And then chip enable, pin 18, is connected to VSP. So it's only enabled, so it's disabled perhaps during, so it goes high, I assume it goes high to blank the CRT, maybe. That would make sense. All right. So a little bit of confusion there in this, but so yeah, let's just quickly power it on and check pin 18. See what activity pin 18 has. Power on. Okay. Oops. Okay, so we're powered on. And pin 18, well, which is this one here, so it's pin 35. So I thought there was some activity. So at the moment it's basically just high. Double check that. And it's just high the whole time. It's just sitting there at around 5 volts. No, oh, no, that's, I just thought, oh, it just went low, but that was because I just pulled it off. So that is interesting. So I can still see address activity. All right, let me show you what I am seeing. Okay, so let me just feel it. Yep, okay, 8070's, 8080's getting warm. So let's just check that VSP pin. So pin 35. Let me just rearranging my probe so it's not all looped around. Okay, just connecting up ground. Ground again. Put that over there so it doesn't touch somewhere on the board. Right, so pin 35 VSP, which I said was video suppression. So that is 40, 39, 38, 37, 36, 35. So that is basically high the whole time from what I can tell. Going out. I cannot see it going low at all. So that would mean, so it's at high all the time. That means that the ROM chip enable is inactive, which would be why there's no data output. So maybe it is the 8275. Why isn't VSP? VSP should be pulsing, shouldn't it, to video suppression. All right, let's have a look. All right, is that getting in the way? Let me just get out of the way. So yeah, so VSP, maybe the issue is the 8275. So VSP output signal is used to blank the video signal to the CRT. Well, we're getting nothing at the moment, so it is blanked. Output is active, so high, I assume. Active, I assume it's active high. Well, yeah, it's not indicated to be active low. Okay. It's active high during horizontal and vertical retrace intervals at the top and bottom lines of a row, if underline is programmed to be a number. Okay. When an end of row or end of screen code is detected, when a DMA underrun occurs at regular intervals, which is 1/16 of the frame frequency for cursor, 1/32 of the frame frequency for character and field attributes to create blinking displays. Okay, well, who knows? I don't think we've got a blinking display. So that is maybe that's the reason. So VSP is not going low at any time. Shift register, right? Yeah. Character generator, external dot clock. Doesn't have anything there about VSP. So maybe video enable status flags. Well, I can't really see that sort of. That's all right. So these are commands. Okay, this is all commands. Right cycle, read cycle, start display command. Okay, well, not device programming instruction set. Light pin detection. Well, they love their light pins back in the 70s and early 80s. So I'm just trying to find anything here about VSP, but I'm wondering maybe I should replace. Maybe I should try replacing. I'm going to have to desolder 40 pins, but I do have a replacement, I believe. I should have a replacement. Row format. Yeah, because VSP is remaining high. It's not. I don't know if there's something else that should be triggering it. General system operation. All right, let me pause this. It's probably getting boring, but I think I will replace the 8275. Maybe that's the issue. All right, the 8275 is off. Not as cleanly as I would like. This is where we have the issue with the 2.5mm Soviet pitch versus 2.54. So you can see we kind of start off okay there, and then as we get towards the end, we're don't really match up. So you can force it in. Now, probably the cheaper dip sockets are better to use. I wanted to use this one because it's got better contacts here, because one of these legs came up, as you can see here. So I'm trying to hold it steady. As you can see, one of these legs came up here when I was desoldering. So I want to just try and make sure I get it down and get a proper contact. Also on the back, this is why I hate desoldering Soviet boards. So a few of these, there's no track on the back. It's just the pin itself, and so a few of these also came off. So it's a bit annoying. Well, probably my fault. Too much heat, but yeah, that's the problem. So yeah, these aren't the best to use on Soviet boards because of the how rigid they are. But for things like where this track has come up, I just like having this extra contact here. So you can force it in, and it will kind of bend a little bit. So yeah. The only other thing is I'm not sure what to do with pin 1. Sorry if that's not in focus. Focus. Pin 1. Because, let me turn this over. Where is it? Pin 1. Yeah, you see again, that little thing, it broke off. So I'm not sure if it was connected to this, or whether it was just, I don't know, it's floating. So on the 8275, it's hang on, let me get it. So it's LC3, which is LS on the Soviet one. So they've got LS 0, 1 and 2, pins 2, 3 and 4, but there is no LS3, pin 1 connected. So was it connected? I don't know. So I got the Radio 86 homebrew reimagining, and it is actually connected on this one through to this 8253, which we don't have on this board. So I don't know what to do now. I'm thinking if it's tight, it might be just tied high. Where was it? It might, that's connected to pin 1 on the EPROM, I think. No, sorry, pin 24. Pin 24 on the EPROM. So if it was connected through, so if it was connected through to pin 24, I think that's the power, is it? Figure a better way to do the handheld shots. Pin 24, yeah, so pin 24 is VCC is 5 volts. So that would make sense to me. If you're not using it, then just tie it high. So I might do that. I might just tie it in. So yeah, not perfect. I'm not happy, but Let's see. All right, I'm getting it in slowly. As you can see, it arches. It turns out this is the biggest I've got in the cheapo. So yeah, I'm going to have to use this one. But you can see it arches up, and main thing is I want to get it in on this side for that track that lifted up. And yeah, so just kind of got to force it in. All right, I can't really do this in this angle. I've got to just sort of try and show you what I'm trying to do, but you can see it's arching because it's not it's not really fitting. It'll fit. I'll force it, but not ideal. Not ideal. I don't know if this will be of any interest. So I've got the ends. I think I've got both ends in. It doesn't really. Oops. There we go. Let's see. Yeah, all right, we'll see how we go. So I don't know if they have what plated through holes, so I don't know. Yeah, I think I'm going to have to do a continuity test on each pin to make sure they all don't go through. So that was the main one I was concerned about there, that the track had lifted up. So I just wanted to make sure. Yeah. All right, we'll see how we go with this, and give it a try, I guess. So, oh yeah, of course. Do I have spares? 8275. So I do have spares. 74198. What's that? That's an 8257 DMA controller. 8275. So I got two of those. All thanks to what's that one there? 8251. Yeah, all thanks to Unicorn Electronics in the US. They able to get a hold of them. Right. See how I go soldering this in. Ladies and gentlemen, we have a signal. Well, we have a flashing cursor. Hey! So, finally, I'm making some progress. As you can see, very, very dodgy. That's where the signal's coming out of at the moment. Yeah, let me get set up and tell you what I've been doing. Power that down so I don't short anything. So, what have I been doing? Okay, so I've been having a look at Sergey's redrawn schematics for his homebrew Radio 86, which is effectively what the Alpha BK is, and they're obviously a lot clearer than the original schematics. So, what was I looking for? Address decode. What was that one? Wasn't it? Yeah. All right, so the image, as far as I can understand, tracing it all back, is okay. So we've got the CRT control of 8275 that we've been looking at. Poker, where's a poker? No, a straight poker. Right, so 8275, which is the CRT controller, which is this fellow here. So you can see I've replaced it, but I'll put the original back in. So yeah, so effectively what we've got here is, I believe, CRT controller, character ROM here, and we've got the CPU there, and D13. We have a 3 to 8 decoder here. So what I was tracing back from here, so basically, when you look at the signal originally, there was no data. So I had a look at the character ROM, and the address lines were being pulsed, but there was no data coming out. And then when you look at the there's two pins. There's a chip enable and an output enable. I think chip enable is always low, so it's active low, so it's tied to ground. I think the output enable was tied to the VSP pin on the 8275, I think. So that's the character ROM there. And we've got the VSP, which is the, yeah, so chip and, okay, so all right, well, this is a larger chip. This isn't a 2716. Anyway, so VSP is tied to the chip enable. And so when I had a look at VSP, it was high all the time. So obviously it's active low. So why wasn't VSP? So VSP was the, sorry, I'll put it in the description, but I have explained it before. So VSP was the CRT blanking or something. Oh, video suppression. So output signal to blank the video signal to CRT. So basically, don't output anything to the CRT, which is what was happening. We were getting nothing on the CRT. So I tried replacing this, but made no difference. Then I realised, oh, okay, there's a chip select on the 8275 as well, CRT chip select that Sergey's labelled it here. So where did the CRT chip select come from? Well, it comes from another one here. So CRT chip select comes out of this address decoder. So it's a 74LS138 or otherwise a K55 ID7, which is this one down here. And I had a look, and basically, yeah, it didn't look like, we've got a 12, 13, 14 coming in, and I couldn't see any activity on those at all. And you can see it's connected to the CPU here. So CRT CS was never being, well, it was always high, I think, so it was never going low. So therefore the 8275 was never being active, which meant the character ROM wasn't. So I figured, well, why isn't, so I figured, okay, I'll swap out the 8080, which is what I just did. Desoldered another 40-pin sucker from a Soviet circuit board, which isn't fun. But, and again, you can see the problem is Soviet chips are 2.5 millimeter pitch, whereas I've got 2.54 millimeter pitch. So we get you got to really force it in. So not perfect, but I'm not in the Soviet Union, so I don't have access to these chips. So anyway, so I whacked in an 8080, and yep, we got a signal. We got a flashing cursor, which is more than what we had before. Before we had nothing, and now we've got a terrible CRT signal. So finally, that aspect is fixed. So now the question is, what? Okay, now what's wrong with it? I was thinking of maybe just installing one of these boards into the case for the Alpha BK, basically cheating. But I know that'll get a lot of dislikes. So I will persevere. So that's the original 8080 there. I'll tidy that one up. And I've got the 8275, which I'll put back in. But yeah, so I've made some progress. I'm going to have a quick break. And then I might continue. Right, so flashing cursor, but there was some text before. So I'm going to try it again. I did try with the Elgato USB capture, but it wasn't happy. So let's power off and power on. Just to prove me wrong. Okay, maybe power off, let the capacitors discharge. Okay, we all dead? Oh man. So, because what I had for a few seconds was Alpha BK. It actually said Alpha BK in text. It was a little corrupt, so maybe there is an issue with the character ROM still. There we go. Alpha BK. But it's like alpha percentage B, and that's not a K. And then it's got percentage 6. So maybe there is still an issue with the character ROM. Oh, okay. No, okay, yeah. Now we've got the correct text. So it was like this. We can go in closer. So it is a bit unstable. As you can see, the text keeps changing. So that to me is maybe character ROM. And then after a while, we just got a blinking cursor. So I'm happy. I'm happy. Finally made some progress. You see how the characters keep changing? So that might be down to the perhaps the character ROM that I was looking at before. So I'd have to desolder that as well. So yeah, I'm really happy. So I guess I could stick it back in the case and see if the keyboard works. I could do a summary. Let's do a summary first. So it's still running. Like I said, so initially when we looked at it, we weren't getting a video signal output. We were getting a video signal, but there was basically no information in it. So if we have a look at this black and white, basically we were getting this. We were getting the negative sync pulse there. But this section here where the actual video was, there was no information at all, as far as I know. I don't even know if it could actually sync. So I don't know, because the screen could pick something up. It went from no video just to, well, nothing. It wasn't even a black screen. So it could pick up that there was something coming in, but there was just no data. So from that we looked at the character ROM, and I could see on the character ROM that the addresses were being pulsed, but there was no data coming out. So then I looked at the chip enable, and basically the chip enable wasn't enabled, or the output enable. It's a bit confusing on this one because it's the program pin as well. Anyway, one of them wasn't enabled, and that comes from the 8275 CRT controller. The VSP pin, which is again, I can't remember, basically the CRT control or something, CRT blanking or something. So I've replaced that one with a genuine, I've replaced the Soviet one, where is it, this one here? Replace the Soviet one with the, as you can see here, what's it called? KR580 VG75 with a genuine 8275 there. That made no difference, and then I realised that there's a chip select pin on the 8275 as well. So having a look at Sergey's Radio 86 schematics, I could see that it was coming from this 3 to 8 decoder. And basically the CRT chip select was never going high, or was never going low, I think, something like that. And so then I checked, and there was no addressing coming into it either. So I thought, okay, well, that's coming from the 8080 directly. So I desoldered the 8080 today, and I put a genuine 8080 in, and replaced the original KR580 VM80A. So that's the two Soviet chips I've replaced. I did put this one back in. The problem is, like I've been saying, it's a 2.5mm pitch. I've only got 2.54mm pitch sockets, so they need to be forced in. And then trying to force a 2.5mm into a 2.54 pitch, it's anyway. So it's probably better to have the Western parts in there. All right, so it's still running. It's still saying Alpha BK. The picture's terrible, but it seems stable now. Cool. I don't know if the keyboard's going to work. It'd be good to clean up the video, but well, let's get it back in the case. Right, this huge, bloody hell, heavy thing. Right, so okay, I've disconnected everything, haven't I? Of course, I remember where everything went, didn't it? Right. So this just slips back into here. Although I do need to undo these screws first. Most of the light. Problem is I get the reflection of the light there, which you guys probably annoying. Here we go. Right, okay. Yeah, it's a really, really well-made case. So that goes back into there, slips onto the SMP58 connector, where everything's connected to. So let me, all right, I'll finish connecting all this up, connecting the power supply back up, and I've made the DIN cable. Well, I was actually I need to fix the DIN cable actually, because the wire came off, and I want to disconnect the power because there is power actually going into the DIN connector, because it was originally planned to have an external UHF modulator box. So that obviously needs power. So the 5-pin DIN's got 3 wires connected to it, whereas it really only needs 2, just ground and signal. And the signal's broken off, and I want to disconnect this, the voltage, so I don't send 12 volts or whatever this thing was sending to its modulator box. Alright, that's in. I'll finish sorting everything else up, and we'll see if the keyboard works. It looks like the whole tab broke off, so that's not a problem. I'll just replace this with a new one, and we'll be good to go. Right, she's all set to go. I've replaced the DIN socket for the video out. Board's back in place. I've got my modified power supply. Well, you know, modern 5-volt regulator there, and I've put some color coding on the DC output there. So I'll close it up and see if this wonderful keyboard works. Right, so this is what it was doing at one stage. So it was doing this, and then I reseeded the firmware ROM, and then it came up with the intermittent. But nothing seems to be happening when I press the keys. I'm not using the output on the machine either. I'm still using my testing cable, because I wasn't getting anything at all. So it still seems to be a bit intermittent. Let me try resetting the ROM again. Okay, resetted the ROM, powering on. Still not happy. Pressing various keys, including stop. Of course, I don't even know if the keyboard does work. This is frustrating. It was working. I should just leave it how it was. And then we get nothing at all. Okay, maybe we didn't. Alright, power back on. Nothing at all. So still, I don't know, this case is makes it very difficult to troubleshoot because it's so fucking heavy. So I'm not sure We can reseat the, we have a look at the ROM and do this one-handed. Can go down. See, it's one of these dodgy Soviet sockets. I'll try seating it in again. Okay, power on. And yeah, still nothing. Should take it out of the case. It was working better out of the case. Alright, I might take it back out of the case. I'm getting a bit fed up with that case, to be honest. Alright, so still... Alright, so we did have it working. It's now not happy again. I just wonder if it's that ROM. Or the socket, to be honest, actually, not the ROM itself, but the socket. Alright, one more time, then I'm going to call it a night. So turn it on. So that's what we get without without the ROM in. So we do get some signal. Okay, power on again. Okay, alright. So that's what it looks like without the ROM. Without the firmware. Alright. Which to me indicates that, you know, the CRT controller is working. Alright, ROM's back in. Oh! Did you see that? Oh! Okay, that's different. Don't know if I'll have to slow that down, I think. Right. Okay, I'm getting a bit tired of this. Looks like I have to replace that ROM socket. Power off one more time. Oh, okay, now we've got a cursor. And then half a screen of text. Okay, that's a new one. So yeah, I'm not keen on desoldering that socket today because I've just, you know, I desoldered the 8080 today, and that was, well, it took me 2 days to do that. Okay, one last time. No, okay, we're getting that now. That's weird. So I reckon maybe it is a firmware issue. Maybe there is an issue with this ROM or the socket. Okay. Well, we got the video working. That was the main thing. We didn't have any video, now we do. Getting there, little by little. Anyway, hopefully that was of some use or of some interest. Bye for now.